Hello. So now that we've actually undistorted our camera, and now that we've actually masked out any moving elements in our scene, okay, we're now in a position to actually track our 3D scene here. So what we're trying to do is actually track the whole scene in 3D. So we're not just tracking an object in 2D like we did with this tracker in the previous tutorial. What we're actually trying to do is track lots of points in this scene and actually reconstruct the movement of our camera that we use to shoot this scene as a virtual 3D camera. Okay, so trying to actually, the best way to look at it is we're not just tracking, we're trying to reconstruct the scene in 3D. Okay, now in order to do this, there's a two-step process. There's tracking points in our scene, and then there's solving our scene. Okay, so both are done within the same node that we're looking at. So what we're going to do is we're going to call up the camera tracking node. Okay, the camera tracker, the camera tracker node. Okay, now keep in mind that the camera tracker node, okay, it's called the camera tracker node because it's not tracking the scene, it's not tracking stuff in the scene, it's using the scene to actually track the camera. Okay, and that's an important thing to understand. Hopefully that will make more sense as we go to the end of the scene. I'm just going to move things up a little bit so we've got a bit more space. Right, okay. So first part of this is we need to have points that we can track. So I'm going to click on here, so we've got our node visible here that we can work on. Great. Okay, now we have got a mask, so I want to select the fact that we have got a source alpha in here. Okay, and then what we need to do is, in order for it to track the camera, it needs to understand some information about our camera. So we need to specify the type of motion. In this case, it's a free camera. It's a handheld camera and it's moving around, so I'm going to select free camera. It might be that I had it on a straight dolly or something, in which case I might go for something like linear motion, or I might have had it on, say, a pedestal, so it's moving on a flat floor, in which case I might go for something like planar motion. But for this one, or I might have had it on a tripod, in which case I'm just going to rotate. I want to track rotation motion. In this case, what I'm doing is it's a free camera, so I'm saying it's handheld and it's going to be moving around. Lens distortion. So what we want to do is say that there's no lens distortion on this, and there's no lens distortion because we've already undistorted this. Okay, now if we hadn't undistorted it and we didn't have that grid, what I could do is just select unknown lenses. Okay, and what that would do is it would use the 3D tracking points that it's tracking in this scene to also work out what the lens distortion would be. Okay, great. But that's not nearly as good as actually doing a distortion grid with this method. Well, no, I wouldn't say not nearly, but it's not as effective or robust as the method that we've used. Okay, so now what we want to do is we want to specify the focal length. So we do know what the focal length was, and the focal length was 34 millimeters. Now, what I should just say about this part here, so I'm talking about here the focal length and the film back size. Both of these elements together contribute what we call the field of view. Okay. Now I'm sure you've done this in another module, but if we make the sensor smaller, it makes the field of view wider for the same focal length. Okay. Well, in fact, sorry, let me rephrase that. If we make the film back size smaller, it makes the field of view narrower for the same focal length. So, for example, this is effectively equivalent to the 35mm film camera, okay? Or in a digital world, say a Canon 5D, which is a 35mm sensor, or any digital camera that's got a 35mm sensor on there. If I decrease this will basically be as if, by making this smaller, it would be as if I was making the focal length longer. It's narrowing the field of view. Okay. the important part is that both of these elements define our field of view, and what we need to do is we need to know what the field of view of the camera is in order to be able to accurately solve the camera. So the computer's not going to be able to understand and solve the movement of the camera if it doesn't know what the field of view of the camera is. Okay, so the key part from your point of view is that you need to know both of these pieces of information. Okay, so you need to know what the focal length of the lens you're using is, and you need to know, so avoid zoom lenses if you can, and avoid things like telescopic tubes and things like that, things that change the focal length to something that we don't know what it is. Okay, okay. Next, we've got the film back. Okay, so another thing you want to know, so just as we want to know what the length of the lens we're using is, we want to know what the size of the film back is. Okay, so in this case we're using a Blackmagic camera, and what's great about this is you've got something called film back presets. So I could go to the Blackmagic website, get the measurements I could get the measurements of my sensor and put them into here, and you could put them in millimeters or inches depending on what size they've given you the size of the sensor. So just to clarify, the film back is effectively the size of the sensor. Okay, so different cameras have different size image sensors. What's really useful here is I've used the Blackmagic Cinema camera, and I can actually there's for known cameras or common cameras, I suppose, Nuke have already put in here those sizes, so you can just select from here. So I can go, right, I've got a Blackmagic, so you might go Canon, you've got the C100, C300, which we've got, and then you might go to digital SLRs, and these are all the different digital SLRs. So you've got all kinds of sort of a whole range of cameras that you can already select from. I've used a Blackmagic, and it was the Cinema camera C2. Okay, and they've also got the pocket camera that we've got as well. So I can click on that, okay, and that's great, and it gives me the film back size automatically. Brilliant. So in short, both of those pieces of data means that I can now accurately reproduce the field of view of the camera. Okay, excellent. Now what we can also do is we can sort of look at some of the settings here to look at sort of features that we're tracking. Okay, so what we can do is I can actually increase the number of features that I'm tracking here. So I might go, let's go up to say to 200. Okay, so this is the number of features it's going to try and track in this scene. Okay, now I'm quite happy with the threshold detection and feature separation settings in here. In fact, actually I might increase the threshold detection a little bit. Okay, all we're doing here is saying that we're telling the computer to only track points. Remember, we want to track high contrast points. We're telling the computer to track only high contrast points here. Feature separation is how evenly do I want it to track features across our scene. Okay, so now what we're going to do, in fact, what I can do is turn on the preview features section. So this is telling me what features it's planning to track here, and you can tell if I change the detection threshold, you can see it's adding extra features to areas which don't have so much contrast. Okay, so I'm going to kind of drop that down a little bit. Okay, and then here I can tell it how many features I want to track. So I could drop this to say 50, and you'll see it's going to track a smaller number of features here. So you can see these are the features it's actually tracking. Okay, and then the separation, if I turn that down, it'll basically track features all in one area. By increasing that number, okay, I'm telling it I want to track features more evenly across the screen. Okay, now that I've done that, I'm kind of ready to do my track. So I can go back to the CameraTracker tab and then basically click track. Okay, I'm just going to wind it back to frame 1. Okay, and I'm just going to go and click track. Okay, so now what it's going to do is going to go through our scene and track all of these points. Now that'll take a while, so what I'm going to do is I'm just going to pause it there. And we're still in the middle of the track here, but I just wanted to point out that you'll notice that it tracks forward and backwards as well. And also, one of the things I didn't point out is that you can see that this alpha mask is working. Notice it's not tracking any points in this area where we've actually placed the mask. Okay, I'm going to pause it again for it to finish. Okay, so now that our track's completed, what I want to do is just go through this. I'm just going to just zoom in here. In fact, if I play this back, you can see that it's taken all those points and it's tracking the movement. You know, it's tracking all those points on the screen. Now, it hasn't it hasn't actually worked out the position of the camera yet. All it's done is just track these points on our screen. Okay. Right, I'm just going to stop it there rather than play it all the way back. But I just wanted to demonstrate that it is tracking those points. Okay. Now, if I just move this down, what we can then do is start looking here and looking at any track points that don't seem to be following, you know, the same sort of path as the other track points. Okay, so any track points that kind of cause a bit of concern. So, for example, this one here. I don't like. So if you select it, you can just simply delete that track point. Okay, this one here. I think I'm happy with most of these track points. So look. Most of these track points are fine. So I'm just going through and just seeing if there's anything that I don't want. I think that'll do as a first pass, but obviously you could go through this in more detail. But all we're trying to do is look at track points that don't seem to be following the same path as the other track points. Okay. So for example, I think, yeah, this one doesn't quite fit for me. That's right. Let's have a look. No, that seems to be fine. Yeah. Okay. So I've gone through there and had a look at that. Now what we can do is what we want to do is take those 2D track points, okay, and the information that we know about this lens that we've put into this system, and then use that to actually work out the movement of the camera itself, okay? And we do that by clicking solve. So this is the solve process now, okay? So if I click on that, okay, so what it's done then is it's taken all these track points and solved the movement of the camera for me. Okay, now what we're looking at here is, in fact, and what I should just demonstrate, if I go into 3DC now, in that solve, what it's done, okay, is it's worked out. It hasn't created a camera yet, but it's worked out where all those points are in 3D space. Okay. Great. And it's difficult at the moment, but you could actually go and check those 3D points and see if you're actually happy with those 3D points and whether those sort of correlate with what you should be seeing. Okay. But before we do that, let's go back to our 2D view. What we're interested in here is we've got this error rate here, and this is what this is doing. It's sort of looking at it and kind of go, you know, all these points give us different information, and it's sort of saying, you know, how close, you know, how close were these points to being correct, to giving us an accurate track. Okay, how close did these points actually line up and corroborate with each other as it did the track? Okay, so what we can do is again, I'm just going to go back to frame 1 and click solve again. Okay, yep, reset the current solve. Great. Okay, it seems to be solving very quickly for some reason, but anyway. Okay, so we've now done that. So now what we want to do is go into auto tracks. Okay, so effectively what we want to do now is to improve this error rate. So we want to try and get this below 1. Okay, so to improve this error rate, what we want to do is some of these tracks are going to be better than others. So we want to analyze all these tracking points now, okay, and actually strip out tracking points that aren't so good, okay, and then resolve based on the good tracking points, okay. So again, I'm just going to click the auto tracks tab. First thing we're going to do is pick out any tracks which are only tracked for a very short period of time. So you can see by the length of these lines, there's some that are only on the screen for a short period of time, and they're probably not going to give us as good a track as some of the other tracks or some of the other track points. So we can click track length min, okay, and then min length. So that's what I want to do. I'm just going to press Control to select both of those, okay? And then what I can do is I can adjust this top slider here to remove any track marks which are, above or below a certain period of time. So I'm definitely going to try and get rid of anything that's below, only 4 frames, okay? There's quite a large number that are only 5 frames, but I'm going to leave those for the moment, okay? So I'm going to say that's the minimum track length, okay? Next thing I'm going to do is I'm going to look at how accurately it is able to track each of these track markers in 2D space, okay? And I'm going to do that by selecting the error RMS, okay, and the max track error option here. So look, okay. And then what I can do, just to get a better look on this, is I can frame this. What I'm going to do is just adjust. So if I just adjust this, so it's this second line down. It's this second slider here that I want to adjust. If I just pull this down here for the moment, okay. If I click on this graph and just press F, it will frame everything up so I can see it a little bit more clearly. So now I can see more clearly what I'm adjusting here, and I really want to get rid of a lot of these initial track points here, and I've got a really good cluster of track points that the computer feels quite confident about, so I'm going to keep those, okay? So that's getting rid of any track points which the computer was unsure about how accurately it was able to track that detail in 2D space, okay? So this tracking in the details within the actual video. Next thing I want to do is I want to click what I want to do is pick track points which, when it came to actually putting them into the 3D solve, didn't corroborate or didn't fit the solution of the other tracks. Okay, so as I'm actually using this information to solve the camera in 3D, some tracking points fit the solution of the position of our camera better than others. Okay, so we're assuming that those that don't fit it again are not tracking properly. So I want to click error track. Okay. In fact, I want to click error max, and then I'm going to click max error. Okay. Again, I can press F to frame this, and it's this bottom slider now that I want to adjust. So again, I'm just going to get rid of all of these at the top here. Again, you don't want to get rid of too many track points. You want to be careful of doing that. Okay. So I'm going to go with that. Now what I can do is go delete unsolved. Okay, and this will permanently delete these track markers and delete rejected. Okay, so it's deleted all those track markers. Now what I want to do is go back to the camera tracker and then click solve again. And you'll see that we're now down to an error rate of 1.16 per frame. Okay, what I would do as well, sorry, just another thing to wind back on as well. When I went into settings here, in fact, yes, no, that's fine. I thought I'd left preview features on, but I hadn't, so that's fine. Okay, let's go back to our auto tracks. So we want to get this to 1 ideally, okay, or 1 or less, okay. So again, I'm going to go back to my auto tracks. I'm going to look at this length thing again. Okay, so I'm going to click. I think it was the length min and min length. Okay, press F to frame that, and I'm tempted to kind of adjust this and get rid of this sort of bulk of tracking markers here. And then what I'm going to do is go back to look at my other ones. So that's my RMS. This is the 2D, checking my 2D tracks. Okay. And I think there's some more I could strip out there. Let's move these out here. You see there's quite a good bulk there that are good. Might even be a bit more aggressive than that. Ooh. Sorry, I just moved the wrong slider there. That's something to be careful of. Okay, let's stick with that. And then I'm going to do my error max and my max error. Again, press that F to frame it. And then I'm just going to be a bit more aggressive with that. Okay. Again, I'm going to go delete unsolved. Yes. Delete rejected. Yes. And then I'm going to go back to my camera tracker. And you can see now we're less than 1. If I click solve, okay, yes. So now we're less than 1. I'm happy with that. Okay, so I'm happy with that as a solve. That seems to that's convincing me that that's now that we've now got a good track on there. Okay. So now what we can do is we can actually, if I just go back to our node graph here, okay. Now what we can do is we can go back to our scene, we can go back to our node graph, and what we want to do is obviously we want to take all this data and be able to use this to actually place 3D objects into our scene. And there's various options you can select, but I'm going to select the Scene Plus option and go Create. And what you'll see is it's basically created all these nodes. So all these nodes below have been created automatically by this camera tracker. And basically what this is doing is it's creating a 3D scene, okay? Let me just demonstrate this for you. I'm going to go into 3D here. It's creating a 3D scene. What I need to do is connect this scanline renderer to the viewer. Okay, here we go, and I press 5. So I'm looking at so now what I'm doing is I'm looking at the 3D scene that's been created by this tracker. So you can see we've got a 3D scene. Here's our camera, okay. Here's our point clouds. So here are all the points in our scene, okay. We can see all of those that it's tracking. That's great. You want to check sort of errant points that are behind the camera or where you wouldn't expect them to be, okay? But you can see it's created a 3D scene with our camera, okay, that's the camera there, our point cloud, okay? And it's putting those into a scene. So this is our scene. So that's the point clouds going into the scene, the camera going into the scene, and then here is our renderer. So the scene, which is the scene, is then fed into our renderer. Okay, and then it's the renderer that we're looking at in order to be able to kind of look at our scene and see what we can see. Now to move between the 3D view that I'm doing here, and again you can move around this 3D view exactly the same way as you might move around Maya. So that's kind of a sort of a standard, that sort of interface, in terms of pressing Alt and using the right, middle and left mouse button to move around. Okay, you can swap between the 2D and 3D scenes here, so you can see those. Okay, and what we can do is, now that we're looking through the scanline renderer, you can see those 2D points and get an idea of, these are 3D points in our scene rendered through the camera. So these aren't 2D track points now. These are 3D points in our scene that are being rendered and then added to our scene. Okay. So notice that this scanline renderer allows us to put a background on there, and notice that here it's taking a copy of the movie and putting it through the lens distortion. Okay, so effectively what we could do is there is no lens distortion on this, but what we could do is, if it was an unknown lens, any distortion data that this tracker had created or figured out from its track would be put into this lens distortion node. So we could copy and use that lens distortion node in the same way that we're doing with this lens distortion node. But as it is, we selected no distortion, so this won't have anything on it, hopefully. If we click on that, yeah, no distortion, so this has got no data on this lens distortion. It's effectively not doing anything, okay? But if we said unknown lens, that would have some data on it, okay? Or we set unknown lens in our camera tracker, that would have had some data in it. Okay, great. Now that we've done that, what we want to do is, you'll notice when we're in our 3D scene, basically the camera is kind of you'll notice that the camera is also moving around. Notice how the camera is moving forward. So this is reproducing the movement of the camera, okay, that was used to shoot the scene. Okay, around the static 3D points. And that's what's giving us this motion here. If we play that back, there we go. Okay, so you can play that back and check the track. Let me just let it preview up to this point here. And you can see that's a pretty solid track. They aren't slipping around. They're doing quite well. So that's our sort of first initial check, if you like, as are these points on the scene. Now, if we go to this 3D scene, you'll see that the camera is basically level. So if we go to frame 1, it treats that as that's where the camera is it's sort of treating the camera as level, and then basically positioning these point clouds in respect to the camera. In effect, basically, the scene we've got an accurate 3D scene, but it doesn't know anything about the actual layout of that scene. It doesn't know what orientation this camera should be. It doesn't know that really this is, most of these are on the floor, and most of these track points should really be on the ground. And so these track points should be kind of flat, rather than sort of going upwards like this, because it doesn't know the layout of the scene. So that the next thing we want to do is kind of try and give it some information about the layout of the scene. So what we want to do is basically to give some idea, a simple way of giving some idea of where this should be in the orientation of this scene. So when we think about what we want to do is try and give information about the orientation of the scene and the scale of the scene. Okay, now in this demonstration, knowing what the scale of the scene isn't so important, but we do need to give it the orientation of the scene. So how we do that is we'll go back to the camera tracker. So I'm going to select the camera tracker, press 2, so that we're now looking at the camera tracker, not the rendered result. Okay, and then if you just move this bar, you should get these tracking lines again. And then what you want to do is get to a point where you've got quite a few tracking lines on the floor that we can select from. So here we are. I'm going to go and press Shift and just select a load of these tracking positions that are on the floor. Okay. And the key thing is to select tracking points that are at different distances, okay? Because it'll give that'll make it more accurate at that point. Then I'm going to kind of go through the scene a little bit, okay? And there's a good number there that kind of exists for a long period of time. But let's select that, and there's some more tracking markers I can select. So I don't need to track everything, but I'm just sort of going through the scene, making sure that every point in this. Oh, sorry, I forgot to press Shift there, so I'm going to have to start again. Do apologise. Let's try and be careful next time. Again, select these, select that one. Okay. Don't want that one. Select that one. Okay. Let's move through. Even more that I can select there. That's great. I think that's enough markers that I've selected. So now that I've selected these tracking markers, what I can do is just go right click and go ground plane set to selected. Okay, but you'll see there's other things I could do. I could well, actually no, this is the best way to do it. So if I go ground plane, let's go set to selected. Okay, and now what we've done is basically say all these tracking markers that we've just selected, they're on the ground. So now when we look at our 3D scene, okay, you'll see, again, I'm just going to look through the camera again. So I'm going to select my scanline renderer, and this is our 3D scene, so you can see the camera. So you'll see that it's put all those points on the ground, look, okay, and yeah, it's put all those points on the ground, and it's put our camera tilting downwards. So now we've got a scene that is acting like, or is laid out, at least in some way, in terms of its orientation, maybe not the scale, is laid out in some way that is similar to how the actual scene that we shot was laid out in real life. And we can also check the track by selecting a if I put in here a wipe, what I can actually do is I can actually check between my, I can kind of see my 3D world and my, but if I select here, I can put a wipe in here. In fact, let's do 3D. And what I'm going to do is, if I select 3D and then say that I'm looking through camera 1, okay, what I can then do, and I'm going to do an over, okay, I can create a wipe here that can give me an idea of, a sense of, you know, I can actually see the ground here. I can get a sense of the ground moving. I can get a sense of these points. So I'm getting a much better idea with this of how my scene's laid out and the sort of solve that I'm getting. Okay, let's just play this. Let's just preview this. So this is just doing a quick preview for me now. Okay, so again, all I did was just select the over. I selected wipe, then over. Okay, and then all I've done is, in fact, let's just pause this. At the moment, my B, which is this bit here, is my read to node, and I don't really want that. What I want it to be is my, I would like that to be my undistorted one, if I can. Scanline renderer 1. Shuffle copy 1, okay. I want it to be shuffle copy 1, okay, because then that's the undistorted version. Let's try that. Okay. So what I'm doing is I've got the result of my scanline renderer, okay, looking through, which is in 3D, looking through the camera, okay, overlaid with what's coming out of the shuffle copy, i.e. the original video, okay, that's undistorted and went into the tracker. Okay, and then what I can do is, by previewing this, I can actually get an idea of how this is all fitting together. And obviously, what I'm interested in is the fact that this is supposed to be our ground plane. So I'm really looking at not just these tracking points now, but this grid. How does this grid line up with being the floor? Okay, so I'll just let this preview generate, and then I'll come back to you. Okay, so I'm really happy with the results of this. So what we've got is, you know, we can see that the clouds, the points in 3D are tracking really nicely with the scene, but also we can see that this ground plane, okay, is really, you know, is really sort of hooked to the floor. Okay, we can really see that it matches where the floor should be. So I'm happy with that track. Okay,